Hello, Fabiola. Thank you for reaching out and asking your question from the 9.3 homework. First, I'm going to just show you what I'm going to be using to answer your question. I'm looking at the 9.3 outline. I'm going to use these right triangle-based definitions of the trig functions. I have a screenshot of that pulled over. I'm also going to be using these three special triangles right here. And as a reference, I'll be using example 5. So what we're doing in this problem is we're asked to evaluate some trig functions at the angle 315 degrees. The ones that we want to find are cosine, cotangent, and secant. So in terms of these definitions, we're interested in the cosine definition, the cotangent definition, and the secant definition. Now these definitions define these trig functions in terms of the sides of a right triangle. So you draw a right triangle, you choose some angle, you have to pick an angle. Relative to that angle, you get a side opposite it, and you get a side adjacent it. You could think of the side opposite it as the y value and the adjacent side as the x value. It also determines a hypotenuse. Based off of those three values of the sides of those triangles, we're able to define these trig functions. Now let's look at an example where we use a triangle to figure out what the values of some trig functions are. So in example 5, it's not very clear here, but we're finding the values of the trig functions for 210 degrees. I'm going to redraw this just so you can see the picture clearly. If I'm going to sketch the angle 210 degrees in standard position, I start off at 0. There's 180 degrees. Right there, so I need to go 30 degrees more to land at 210 degrees. So I have the 210 degree angle drawn. We form our right triangle right here from the terminal ray to the closest x-axis. There is our right triangle. We know that if that was 180 degrees, that this little angle right inside here must be 30 degrees. There's the right angle. That has to be 60 degrees. We know there's 180 degrees in a triangle. So what we actually have here is a 30, 60, 90 triangle. And I took a screenshot of the 30, 60, 90 triangle from the outline that tells us in a 30, 60, 90 triangle, the ratios of the triangle are that the side opposite the 30 has length 1. So the side opposite the 30 has length 1. The side opposite the 60 has length root 3. So the side opposite the 60 has length root 3. And the hypotenuse is 2. So our hypotenuse is 2. So in terms of the sides of a triangle, thinking about where the 30 is and that root 3. So the x is a root 3, but it's negative because we did go left. This did land in quadrant 3, where both x and y are negative. The y is that negative 1. So on the actual sides of the triangle, I just put positive numbers, but then I go think about what quadrant the angle landed in. And r is 2. R doesn't really have a sign. It represents the hypotenuse. It represents a radius of a circle. Also, you could think of it like that if you thought about a circle like this. But that's beside the point. Just know that R does not necessarily have a sign. Okay, so we have this x value. We have the y value. We've thought about what the adjacent and the opposite are, right? Relative to the 30, we can see that the root 3 is the adjacent side, the 1 is the opposite side, and the 2 is the hypotenuse. So let's go, and now, then we could use those values to fill out whatever we were missing. Okay, so let's take a look now at applying that to your problem, now that that's explained example 5. I'm going to sketch a 315 degree angle. 315 degrees, so here's 90 degrees, starts off at 0. Here's 180 degrees. Here's 270 degrees. So 315 degrees is right there, right? Because I'd have to go to 270, but then I'd have to go 45 degrees more. Right? So that's right there. From here, I can draw a triangle. Let me just move this 270 degree down. Don't get confused here. Really, it doesn't matter. You could draw this triangle, or you could draw this triangle. It doesn't really matter. They're the same triangle. What's important, though, is that you have to know exactly what this angle is right here. So if the whole thing was 315, and we know that going up to the the bottom negative y-axis is 270, then that blue angle in there is the 45 degrees, because that's 315 minus 270. So this is a 45-degree angle. I'm going to just clean this up a bit. There's my right triangle. This means this is also a 45-degree angle. So instead of looking at the 30, 60 right triangle, I would need to go back to the outline notes and take a look at the 45, 45, 90 triangle. So I'm going to scroll back up right here. There's another triangle right here, 45, 45 right triangle. Let's drop that in there. So in a 45, 45 triangle, we can see the ratios are a little different. The sides opposite both the 45s are both 1. So opposite the 45 is a 1, opposite the 45 is a 1, and the hypotenuse is the square root 2. Okay. And we're using this 45 as our point of reference. So our opposite is 1, our adjacent is 1, and our hypotenuse is the square root of 2. So let's just take a look at some of the values that they already gave you just to explain how they're getting some answers here. So for instance, they've already said that sine is equal to negative root 2 over 2. The negative comes because this is happening in quadrant 4, where x is positive and y is negative. And sine is y over r. So sine has the sign of y. So they got the negative root 2 over 2 because sine is opposite over hypotenuse. Opposite side is 1. Hypotenuse is root 2. We said it was negative because it's in quadrant 4. And then they rationalized it by multiplying it by root 2 over root 2, just to get rid of the 2 in the denominator, of the square roots in the denominator. Because root 2 times root 2 is root 4, which is simply 2 with no more square root. Okay. So let's look at another example. Let's actually go through and find cosine. Let's find cosine together. So this cosine 1, cosine of our angle is 315 degrees in this case. Definition of cosine is adjacent over hypotenuse. The adjacent side is 1. The hypotenuse side is root 2. Let's think about what sine this would be. Cosine is x over r. In this case, x is a positive 1. Y is a negative 1. So I'm looking at the sides of these triangles. Y went down 1. R is always considered to be positive. So in this case, cosine will be positive. In quad 4, x is positive. I'll rationalize this, multiplying it by root 2 over root 2. And I get root 2 over 2. A positive root 2 over 2 for cosine of theta. So you would need to still go through and use this cotangent and secant definitions here. Use the hypotenuse and the adjacent sides and the opposite sides of that triangle to answer those questions. Please let me know if that answered your question. If not, I'm happy to meet with you on Zoom. Just give me a shout.